Okay, I think we're, as the song has naturally come to the end, we're gonna kick off. Good afternoon, everybody, and welcome to this session on UK plan for chips, driving the UK semiconductor strategy forward. I'm Sue Daley. I'm Director of Technology and Innovation at TechUK. For those of you that don't know us, TechUK, we are the UK Technology Trade Association, and it's my pleasure to be your chair for this panel discussion. We're here with a brilliant panel. Just note, if you were here to see Richard Sellers, fortunately Richard isn't able to join us, but we've got upgraded panel. Don't tell Richard. But Caroline has stood in for Richard today, and we're very thrilled that you're here. So welcome. So we'll get to the brilliant panel, and we're going to hear what they think we need to do in terms of steps to move forward. But before this discussion, I wanted to perhaps just set the scene, give you a brief overview and a reminder of the UK's national semiconductor strategy and TechUK's UK plan for chips, which we published recently. So TechUK, as I said, we're the Technology Trade Association. We have been an advocate for the semiconductor industry for a number of years now. This has included the publication of our UK plan for chips back in 2023, as well as the updated version, which came out in February this year. And if you haven't checked that out, don't do it right now, obviously, but please go and check that out. So we represent over 1,100 members of the UK tech ecosystem, spanning everybody from the design manufacturers of semiconductors, end users, of course, and consumer electronic companies. And we're also delighted to be playing a leading role in the CHIPS Coalition, the UK CHIPS Coalition. Open to all, it's a prominent convening body and voice alongside TechUK and TechWorks and global tech advocates. We work together to continuously drive forward UK semiconductor sector. We're also proud at TechUK to host a number of different events. I'm very much looking at the convergence between semiconductors and, which might come up today, AI, net zero, future vehicles, quantum. And actually those sessions were just held this month alone. So it's a busy time. If you've got any questions on TechUK or how you could get involved in our work, please grab me. Or Ellis, do you want to just pop your hand up? Who's our program manager for semiconductors, and I'm sure he can help. So why are we here today? Well, of course, semiconductors, which, as we all know, are the foundation of our modern digital technology, pioneering everything from everyday consumer electronics, vehicles, defense, healthcare, to data centers powering AI. It's an industry projected to reach $1 trillion by 2030, which isn't that far away. So securing the UK's position in this critical sector is essential for economic growth, alongside our tech leadership and national resilience. Alongside their foundational role in the modern economy, semiconductors are also part of a global supply chain that's significantly susceptible to external shocks. And the semiconductor supply shortage we saw back in 2020 was estimated to have reduced global GDP by 1%. So as well as economic insecurity, supply chain disruption can also threaten critical national infrastructure, making the semiconductor supply chain essential to UK resilience. So as such, semiconductor capabilities have assumed critical importance for many governments around the world and also the UK. So in 2023, the UK government announced a national semiconductor strategy, which I'm sure you've all read, which TechUK was delighted to see a lot of our recommendations made in our UK plan for chips included in that strategy. It outlines a 20-year plan and path to UK leadership, £1 billion in targeted support across IP, design, R&D, and compound semiconductors. Now, this £1 billion figure, on the face of it, looks dwarfed by other commitments from countries such as the US, the EU, China, and South Korea. However, I think the UK's goals differed from those strategies. Instead, it seeks to look at what's the unique selling points for the UK and how do we bolster that and how do we drive that forward, and maybe that's something we'll talk about in the panel as well. This approach has been broadly welcomed, and while the strategy sets out that vision that we needed, we think progress since its launch has been incremental. So to ensure the UK capitalizes on its semiconductor potential, diverse action, we believe, is now needed. So in February 2025, TechUK published our latest report, the UK Plan for Chips. And we outlined 3 missions the UK government, we think, must pursue to position the UK as a global leader in semiconductors. Firstly, turn our strengths into leadership. Secondly, ensure greater financial investment into those strengths and bolster those strengths, as well as capitalize on the UK's strength in the global supply chain by forming strategic partnerships with peer countries, so looking internationally. So there's a lot more detail in the report, but I actually want to leave it there because I know you really want to hear what our amazing panel have to say about how do we move forward. What do our industry experts think are the biggest opportunities in realizing UK Semiconductor's full potential, and how do we move forward? So what are the steps we need to take going forward? So I'm delighted to be joined by a wonderful panel. I'm going to ask them to introduce themselves and then we'll kick off the discussion. So Caroline, can I ask you just to briefly, and thank you so much for being here. I know at very short notice as well.
No problem at all. Good afternoon, everybody, and so it's a pleasure to be here. So I'm CEO of KUBOS Semiconductors. We're developing a new compound semiconductor material, and we're targeting our first market at micro-LED displays and red micro-LEDs. There's currently a problem in the market with low efficiency for red micro-LEDs, and it's stalling the takeoff of that market. So we can address our cubic GaN technology at that market. So that's a brief introduction of us.
Fascinating. Emre, great to have you with us.
Thank you. My name is Emre Ozer. I'm the Senior Director of Processor Development at Pragmatic Semiconductor. So Pragmatic designs and manufactures chips on flexible substrates. And we have a few fabs located in the Northeast England. And they manufacture flexible ICs in a sustainable manner.
Great to have you with us. And Janet, welcome.
Thank you. I'm Janet Collyer. I'm an engineer by training, as my corporate career was in semiconductors. I started off life as a semiconductor design engineer. Today I chair two startups, one called Quantum Dice that provides quantum random number key generation, and also Mac 42, which provides a AI-based simulation acceleration as a companion to a simulator. I'm also on the board of the Aerospace Technology Institute that sets the strategy for UK Aerospace and spends around £500 million a year doing that because that's what it takes to test these things out. And I also serve on the Government Semiconductor Advisory Panel, which I will not be talking about because I don't represent the government here. So I'll defer those questions back to Sue.
Thank you, Janet. I was going to clarify that as well. So two notices to the room. One, Janet was awarded an MBE in the New Year's Honours List for her services. So congratulations, Janet, as well. Very well deserved. And also that Janet, while sits on the advisory board or committee, is not representing and doesn't speak for the government. So she's not a representative of DSIT, the government department, but very much an independent member. So with those parish notices, if anybody knows what that looks like, let's kick on with our questions. So maybe let's start off with where are we right now with the current state of play for the UK's semiconductor sector? Where do we think we are? And maybe how is the semiconductor strategy helping us in terms of moving us forward? Caroline, where do you think we are in terms of the current state of play before we look at what do we need to do, move forward? Where are we right now?
Yeah, I think, I've been 32 years now in the industry, starting in silicon, moving to compound semiconductors. So I've got a sort of a bird's eye view of both segments. I do think that the industry sort of generically is on the up, partly driven by demand for new hardware platforms. So thanks to the software guys in the room, and the new ideas that are being imagined by the consumers and the end customers in terms of where the technology can play out. But I think whilst we are on the up, even to where the industry was when I started out, we've still got a long way to get back to that point. And it's going to look very different. It's a very different world that we're sort of going forward into. We've got many new technologies, some of which we'll talk about today, of course. And it's a very exciting time. But we can't do everything. And we have to be realistic across the UK as to, where our strengths are, where the real opportunities are for our technologies, and how we can then get them to market. Because, we do suffer, and I don't mean that in a negative sense, sense, I mean actually in a positive sense, from lots of technologies coming out of the universities. And the company I represent was spun out of Cambridge University on the technology side. So we come from the materials department there. So, there's lots and lots, and there's other companies that were spun out of the same department. So, we're very rich in ideas and technology. But that technology is nothing without an end consumer, an end market, and an opportunity. So it's got to flow all the way through. And one of the things that we lack today is that end customer base being in the UK. It's not there today in any strength. And again, when I started out, we could drive up the road a few hours, and a company spending $80 million, and that's nearly 30 years ago, on semiconductors alone. We don't have that customer base in the UK at the moment. So I think there's things that we can do on a wider scale to attract those, the inward investment, the customers more locally, because it's, from my experience, a lot easier to deal with a customer who's a couple of hours down the road than one that's in a different time zone with a different language, and sort of 8 hours away. And, the geopolitical situation is making that even more challenging today.
Janet, is that your perspective in terms of where we are as well? I'm also thinking, as Caroline's talking about, obviously we've got the national strategy, but we've also got a quantum strategy and an AI strategy and an industrial strategy. So, and if those other technologies are key, it's about joining all this up, right? But where's your view of where we are right now?
I think it's a really, really good time to be in the semiconductor business.
I mean, it
today.
seems key to everything, right?
Absolutely. It appears everywhere. My mother-in-law was amazed when I said to her, and she's known me for 40 years, said, wow, I didn't realize semiconductors are in my phone. I said, yes, without that. And so we get everywhere as semiconductors. And one thing, just a shout out for hardware pioneers. I had a quick tour around the site, and all of them were producing things that contained semiconductors or had an association with semiconductors at some point in their lives. So, and as you know, the way the value chain goes, the thing at the bottom of the value chain has the lowest profit, and as you go up, the profit margins increase. So semiconductors are enabling other things to make money, and because we're making more semiconductors, there's more profit in semiconductors as well. And so to your question, I think semiconductors are just the unknown part of the strategies for AI. But for semiconductors, you wouldn't have had an AI strategy. Industrial strategy would be there, but would have been behind other people. It's just, you can't avoid semiconductors. And I hope, one of my dreams, Sue, is that when I mentor women and I ask them, what do you want to be? And the biggest answer by far is aerospace engineer, followed closely by mechanical engineer, followed closely by maybe biotech or something. And so my dream is that they say, I want to be a semiconductor engineer, because there's so much work there to be done. You see numbers about the semiconductor business growing by 70%. By 2030, and that's just by the volume, the sheer volume, let alone the many different pieces inside there. So,
let's get to that point. Emre, good time to be in semiconductors then, and in the UK, how can we build on the strengths that we have here in the UK? What's your view of in terms of, is it going to be those emerging technologies that help move us forward, or what do you think we need to be focusing on?
I mean, we need to first look at our strengths. So we UK is not is invested in niche semiconductors, I would say, like flexible electronics, compound semiconductors, and not the advanced silicon fabrication, but there are opportunities there as well, and we have very good science base in terms of fundamental research in universities. And also ML and AI research is very strong, especially in universities, where many of these key professors are snapped by the big internet companies like Google and Amazon, and we need those expertise. So I see semiconductor as a catalyst technology. without the semiconductor, you can't really do quantum computing or automotive. Automotive is a big giant computer now. It has like
Yeah.
1,000 ECUs. Is a big robot essentially. The advanced manufacturing as well. And I also see the AI ML as a catalyst technology. So these two catalyst technologies are enabling innovation in every sector. But they're also two co-catalysts to each other. So if you want to build the best AI model, you need to build the more efficient or the most efficient chip.
Yeah.
But if you also develop advanced AI models, you can streamline the semiconductor production from fabrication to chip design. People using chat GPTs to design microprocessors today. I mean, it's just the very primitive stage, but we will see that the chip design will be automated as well. So, but what I observe as well, that is very fragmented. We are very strong in certain areas, but we need to collaborate more often. The nature of this collaboration can be centralized or decentralized, but we can maybe talk about that later.
Yeah. Caroline, what's your view on how we build on those strengths, and is collaboration, and because in my head I've got like the kind of NASA moonshot, what do we want to achieve, and then how do we come all together to achieve it? What do you think in terms of what do we need to, or how do we need to build on our strengths? What do you think should be we're talking next steps, the focus?
Yeah, I think obviously we're stronger as the rather than just parts. Where the sum of the parts, we're much stronger. What we've noticed around the UK is sort of pockets of expertise, and in some ways, some of these pockets are almost competing with other pockets of expertise around the UK. And I know there's some people in the room who feel very strongly, as I do, that, the competition is outside of the UK for us in our next stages of development of semiconductors, not within the UK. And it's a time for us to unite, not to pitch, one design centre against another design centre, but to see how we can collaborate. One of the challenges we have is we're not always aware of what the other sites are doing. So we do need to spend some time understanding that and how we can dovetail together and, get the premise of, this synergistic view of the, 1 and 1 equals 3. And if we can do some of that and be smart about it, then I think it will get us there, much, much quicker. I just wanted to pick on Emre's point. Whilst when you have known quantities, AI is very good at taking information. I'll give you an example. It was about 12 months ago. There was you may have heard it on the radio, but they said, will AI have found 225,000 new materials? Fantastic. But it doesn't know how to make them. And that's a really good example of it can take you so far, and we have to embrace, the technology, these new aids, technologies, devices, but we also have to keep them in context that they're not a panacea.
Yeah, and making sure people in the supply chain or people in the research will have the skills and the expertise, that we don't lose that to then go, well, I can make that, or I understand how that works.
Yeah, absolutely.
So, Janet, love to get your view on this in terms of strengths. And what I keep coming back to in my mind is collaboration, great. How do we all unite? Great. But also, how do we, access to finance is so key, right, for the UK semiconductor sector and industry. What do we need to do to get that right?
So that's that's a headache. Most CEOs, I hope Caroline is nodding furiously here. They're always thinking, where's the money going to come from? Where's the next tranche of money going to come from? And semiconductors are expensive. So to do one chip, you're probably looking at today between 50 and 100 million. And that's not a very complicated chip. An AI chip will be 200 million pounds. So it's serious money. And that's just a chip. You need the system and everything else with it. So there's a need for thinking big, and that it used to be a strength in the UK. It kind of ceased to be a strength for semiconductors. You'll get big things for roads and hospitals and train stations. That big money's there for that. But for semiconductors, it's having to relearn that habit and convince investors that, yes, you will have to wait a bit longer for your money. It's not going to be a 3 years, maybe like a 6 to 10 year, but boy, will you make a lot of money. And I think an example is NVIDIA, because that's a very big example at the moment, where they can't actually manufacture fast enough to supply all the customers that they want to supply. So that people are on rations for that. So it's a very fast growing company. The market cap has gone really high. So that's an example that semiconductors can make money, but it just takes time, and it takes the whole supply chain and the ecosystem to do that. So back to the collaboration again. You do need to collaborate, but finance needs to be more flexible and say, yes, you're making chips, I'll give you the same access as I'd give a hospital or something else that is something that I can touch. So yeah, I think that's coming now. So, and Pragmatic is a very good example of a company that is scaling, and it's still here. They're still in the UK.
Yeah.
There's so many companies that they scale and they end up either in usually in America, sometimes in Asia, or even further afield than that. So it is there. We just need seven of these every year.
And I went to
Only 7.
Yeah, only 7, no more than 7. Emre, I was very thrilled to go to the launch of your new facility up in the north of England.
Durham.
Yeah. Which is amazing to see. And Janet's right in terms of it is possible. Just how do we do more of that? How do we do more of that in the UK? But of course, global collaboration, we can't ignore it. Global collaboration is important to this industry, important to the UK as well in terms of, if I'm right, if we're designing, if we're developing them, then it's, how do we export that around the world? So could global collaboration benefit, or how can global collaboration benefit UK semiconductor companies? Would love your view there.
Yeah, I mean, I will start with the skilled workers. So this is an ongoing issue. I'm sure.
Yeah.
The other companies in the UK will agree with me. There's a shortage of skilled, especially in semiconductor industry, whether it's process engineering or chip design.
Yeah.
I have to admit that we struggle to find people in the UK. So
Yeah.
and we all resort to outside of UK. But as you know, the challenges are the visas, or the cost of visas, and the time taking to get those visas.
Yeah.
That's an important thing that will that will increase our outreach to beyond UK. So that's something we need to remedy. Maybe this is I guess the key question to the government for help here. The second one is the customers. Most of our customers are again not based in UK but everywhere around the world. So that's very important, and also the some of the supply chain partners. So we can't really do everything ourselves. If we build a flex IC, maybe the PC, you attach this to or assemble this to a flexible PCB, which is done outside of the UK. So that's important. So keeping the partners. I'm not going to go into this trade war things that are happening at the moment, but this is very important. We need to work with the supply chain partners.
Yeah, and they are global, right? And they are all over the place. So collaboration is important, but it's how do you get collaboration right, Caroline? What are you seeing?
Yeah, we're fabulous, and I often share with people, I think the extent of our capital equipment is our PCs, phones, and a soldering iron. And we're making a new material in semiconductors. So we rely heavily on our partners, which is the universities, also some of the companies across the UK that have basically built businesses around developing epitaxy. We process our devices into LEDs today as all part of our R&D process. But we're limited by what we can access in the UK. And so we've had to go overseas to partners, sort of reluctantly, really, in some ways, because it's harder for us, travel adds costs, things like that, time it takes, it's not ideal. And, so it's better to have the equipment close in one place where you can characterize and test and have a very fast iteration. But we don't have that choice. So we have to make sure that we can work, with partners, and you have to, even export licensing, ITAR regulations, you have to be careful what you do and where you do it, because you might end up sort of surreptitiously exposing the business to either leaky IP from the business, or for essentially the parts of the business to be acquired by governments that wasn't intended. So you have to very quickly learn a lot of these things, and now we're in a fast-moving, changing environment. You have to be sure of those decisions, with those partners, on the supply chain side. Very important.
So, and we raise it in terms of what government could do to help and support on the skills side and the challenges around visas and access to talent. And Janet, love your views on this. But I'm going to Caroline first, in terms of given that and given those challenges, what role could government play, or what does industry need from government in terms of being a customer, or commercializing, or driving adoption, or driving more take-up of these technologies here in the UK, or supporting the design and the development of these technologies here in the UK? What would you say, or what if government were here, what would be your ask?
Yeah, I mean,
you already had one.
I have to say, first of all, that, I think that the government is definitely listening. DSIT's definitely listening to the industry at the moment. Yeah. So we're in a very strong position to be able to share our views. We do know that you need those views to be united. And we're very pleased to see the next phase, which is the potential of a National Semiconductor Centre to be able to support the industry further. So there's lots of exciting things going on and coming from DSIT specifically, but we do know that the purse strings are quite tight, and obviously news we've had this week puts more pressure on that situation. So that it's not unbounded, and we have to be realistic in what we can expect. So I think what we're looking for, we are looking for clarity from our side. We'll be targeting a Series A investment round later this year. And to be able to achieve, the goals that we're setting ourselves, we need a stable market, a stable economy. Investors will not invest in something that's, still a few years away from coming into the market, so that, it has risk attached to it, because we are a new material. We are solving a major problem. It's very good, but it's we need patient capital. To Janet's point, we always talk about patient capital in the industry. Well, if you've got a very fast fluctuating market, that patient capital that people want to get in and get out very quickly, not be in an investment for 3 to 5 years, where they just can't possibly envisage what, let alone what we're doing, what the market's going to be doing in that time frame. So stability at the moment for a business like ours, as we go from seed to Series A, is going to be really important. And how that gets set up by the government is going to be key.
Yeah. Janet, love any views, and I know you don't speak for DSIT and the government, but any views on that, or call to action as we're wrapping up, because we're coming to the end of time, believe it or not. Call to action in terms of what you think we need to do in terms of next steps.
So I think a lot has been said about finance, so I'll focus my next step on skills.
Maybe just use it.
A lot has been said about finance. I'll focus my final word on skills. It starts early. So if you know any 8-year-olds, tell them that semiconductors is the place to be, because it takes that long. And these children now, when you see how they're taught very differently from the way we were taught, they know so much and they have so much choice. So they could do any job, so long as they can do critical thinking and are reasonably comfortable with explaining what they do. They don't even have to be mathematicians. So all of them need just many different ways of getting them to not be a glamour model or not be, a forklift truck driver, because they can do so much more. And so encourage them that, yes, you too could be out there doing a really high-tech job. And so the government to create an environment that makes it possible for someone to dream to do what many of you're here today, so you must already be doing very complex stuff, that they can do it too. So catch them early, train them, and attract them into the business, because it's going to be harder and harder to get people. The demographics know that the birth rate is going down, so there'll be fewer people. They've got much more choice, and please diversify it like crazy. Just looking around the audience, I think maybe we're about 15%, if I'm generous, on women. But in medicine, it's 50-50. So get more women to apply for these jobs as well. It's not a dirty profession at all. It's a very clean profession. So go out and get some more engineers into. That's my
absolutely.
approach.
It's all on all of us to do that.
Yes,
and the clear message being, and there are opportunities to do this here in the UK, right, is definitely something that we need to unite around as well. But I mean, perhaps last word for you in terms of key message for the audience or call to action. What would yours be?
So I'm a great fan of IMEC in Belgium and Fraunhofer in Germany. And I think we need one of these or combination of these. So how they work is they are public-private partnership organizations, and they focus on certain areas. IMEC focuses on semiconductor, Fraunhofer looks into more in the systems as well as semiconductor. But so our point of view is that semiconductor is a catalyst technology. AI is a catalyst technology. Maybe we can build or with the not just we shouldn't expect everything from the government, but it should be a public-private partnership similar to one of these organizations. But the core will be semiconductor and ML, and everybody else will come because we are the catalyst technologies, and all other sectors will come to us. And there will be more collaboration. Today, there is no one-stop shop like this type of model.
Well, very interesting and inspiring thoughts and ideas, I think, there. And now I've got the Kevin Costner movie Field of Dreams in my head of, if you build it, they will come. So it's up to all of us to build it. Well, look, we are sadly out of time. This goes so quickly, but I'm sure our panelists will all be around if you want to grab someone and have a chat afterwards. But please thank them in the normal way for a fascinating conversation. To Caroline, to Emre, and to Janet, thank you so much for being with us today.